All right, kids, review time for your exponential functions quiz, the last quiz of the semester. So we're going to go over this a page at a time, and hopefully by the end of it you're feeling pretty confident. First, 3 questions say determine the base and exponent of each exponential function below. So you want to remember that in this case our formula is going to be a times b to the power of x. B is the base, x is the exponent. Whatever is up in the exponent spot is going to be your exponent actually. So for the first question we have 3, 3/5, and 3x. Well, the number immediately attached to the exponent is going to be my base, so that's 3/5. My exponent is going to be 2x. Okay. Next question, negative 0.25 times 7.91 to the power of x. Don't be scared off by decimals or negatives or anything like that. All we're doing is figuring out where things are. So the thing inside the parentheses attached to x is going to be my base. The thing up high is going to be my exponent. Next question, much simpler looking. It says 2 times 9 to the power of x. Again, the thing immediately attached is going to be my base, and the thing up high is going to be my exponent. Pretty simple. Number 4, 5, and 6 say determine if each example below is exponential or not. If so, find the base for each. So you won't necessarily have to fill in the base for all 3 of these. It depends on whether or not they are actually exponential. So what we're going to do here is, first you want to look at your x's and make sure they're going in sequential order, +1, +1, and they all are. Made sure they all were. Then you're going to determine what the change is from one y value to the next. Well, from 5 to 3 is a change of -2. From 3 to 1 is a change of -2. From 1 to -1, -2. And from -1 to -3 is also -2. So they have a consistent change, but it's subtraction. We're subtracting 2 each time. When it's exponential, it will be a multiplicative change. It'll be a multiplier each time. So because these are all minus, this is a no. Okay, you don't need to put anything here for the base. Okay, just put none. Next one. Again, go ahead and take a look at the change to each one. 5 to 10 is +5, but it's also times 2. 10 to 20 is times 2. 20 to 40 is times 2. And 40 to 80 is also times 2. So we're multiplying by 2 each time. If we multiply each time, that is exponential. And you know that the base is going to be the multiplier for each of these. So in this case, my base would be 2. Last one. We have -1/3, -1, -3, -9, -27. We can figure out the -1/3 if we really want to, but since we have all these lovely whole numbers, I'm going to sort of ignore this one and move on to the easier ones. So from -1 to -3 is times 3. From -3 to -9 is times 3. From -9 to -27 is times 3. Now, one of the things that was a little bit tricky about this is it's not times -3. Okay, -1 to -3 is times +3. If it was times -3, the signs would be changing back and forth every time. So in this case, this is exponential because we're multiplying by the same value each time. So that's a yes. And the base is 3. Okay, not -3. -3 would be wrong. Number 7, Jackie and Judy are selling flowers. Each day their business grows as they sell 3 times as many flowers as the previous day. On the first day of business, they sold 4 roses. And the number of roses sold on each day after that is represented by the equation y equals 4 times 3 to the power of x. So, first question is how many flowers they sell at the beginning? Well, remember, you can always read the question to find the answers. Okay? On the first day of business, they sold 4 roses. A, 4 roses. How many flowers they sell on day 4? Well, remember we have 2 variables, time and money. Time is almost always x. In this case it is definitely x. So we're going to plug this into the equation and figure out when x equals 4, what is y. So I have 4 times 3 to the power of x. Go to my table. When x equals 4, y equals 324. Not bad for a new business. Approximately when will they have sold flowers to every Berkner student, which is roughly 3,000 students, maybe a little bit less than that these days. But that is going to be on the y column because the y column is number of flowers. If we scroll down, we've got 2,916. That's approximate. If we go to the next one, it goes way, way, way higher. So that's way out of bounds. I would say on day 6, they will have sold to about every student. Day 6, 2,916 flowers. Okay, there's that one. Number 8, the pressure in a balloon is measured in PSI, which stands for pounds per square inch. The pressure decreases each hour after it is inflated. The air pressure in the balloon can be represented by the exponential function y equals 12 times 0.8 to the power of x. So remember, pressure decreases. You can think of it as a balloon, and as time goes on, they kind of shrivel up. So that means that the air pressure is getting less. Letter A says, what is the original air pressure of the balloon in PSI? Remember, if we're looking at this formula, y equals a times b to the power of x, that a is the value when x equals 0, or 0 time. So this is going to be very important. All right. So the a value, 12, is my original PSI. 12 PSI. That just comes from here. What is the air pressure after 2 hours? Well, lucky for us, we can plug this into the calculator. So let's go back. We'll plug this new equation into the calculator. 12 times 0.8 to the power of x. Okay. And hours is times. We're going to go to x equals 2. 7.68 PSI. And then how many hours will it take for to have an air pressure less than 1 PSI? Well, PSI is going to be on the right-hand side. And it says we want y to be less than 1. So the first time y is less than 1 will be our answer. We go ahead and scroll down. Still at 2.5, so we had to keep going. 2.1, 1.6, 1.2, 1.03, and there we have it. At 12, it has 0.82 PSI. So this would be 12 hours. In this case, you don't want to use the one right above that's actually closer to 1 because it specifically says less than 1 PSI. So it needs to be the first number that is less than 1 PSI, not just above 1. Okay, very important. All right, we'll take a pause and go to page 2.